took independently. That time I came to know some points. That's why I want to explain to you. So suppose the first the experiment, as per the lab manual that you can write. I want to take generalized this thing. Okay. Say to perform various turning operations on the given mild steel workpiece as per the given drawing. So the length of the workpiece is 150, and this is center drill. By using the center drill, you have to make this hole, because last time this type of job we have given students, they don't know that time the center drill, etc. This thing in the final exam we will give this type of job, and you have to write the sequence of operation, all these things. So initially we will take, this is maximum dia is 23, so 25 rod is available. So initially we will keep outside say 150 plus 30 or so extra, or 150 now we will take first, and this in this side we will keep in 3-jaw check. Okay, the first is the sequence of operation. Initially this face to be facing, we have to do facing operation. That is the first step for any job, because last I think in the first class I told facing is not only for leveling. Say reference plane we are making, so from this surface we will take the other dimensions. So this is the reference plane, that one by facing operation we will perform, and during the procedure you have to write keeping the tool at some angle and feed is perpendicular to the axis of the workpiece. These feed, depth of cut, these things you have to mention in the procedure. Okay, so the first one is facing. Next, in the tail stock we have to keep the center drill, and we have to make the center drill hole, because why this drill hole was given more than 150 is there, so overhanging that problem will come. So here after facing and center drilling, we will keep with the dead center support. That is the purpose of this drill hole. So here tail stock and dead center support we will take. So right, second operation is center drilling. Third step is plane turning to reduce to 25 to 23 mm. 25 mm is the rod dia, and initially we have to see any job what is the maximum dia. Here 23, 23, 23. So 23 we have to do, that is the plane turning, right? And next is marking of the dimensions on the workpiece. So because this is 25, next 15 mm, next 25, 15, 25, 5, 15, 15. Or one by one also we can take, but initially after 23 dia line we can mark on the workpiece. Okay. Next is step turning. Step turning is this surface here, that is 19 mm. 19 mm, this one, and afterwards groove cutting, because between, that's why we call it as groove cutting. This one, this and this one. Here there is no tool change, because tool change etc. means it takes more time. The sequence of operations, it gives the optimum cutting time. For that purpose only, in a sequence we have to do. So that is minimum tool change, like that. We have to keep in mind. Okay, groove cutting. 1, 2, 3. That's why 18 mm at 3 places. And next.
Your phone needs a mobile or Wi-Fi connection first.
Next is chamfering. Say this surface, this, and here it is required. Why? Because during threading operation, if slight the chamfering is there, it will run smoothly during thread cutting. The chamfering purpose is, if any say while cutting, if any burr is there, or any projection, we are removing. Main here, during thread cutting, it will go smoothly. There is say sudden jerk will not be there. That is the thing. So chamfering. And next one is taper turning. This one here actually is 23. This is here dia. So this dimension is 18 and 23. By using formula, we have to find out alpha. Tan alpha equal to capital D minus small d by 2L. That is alpha here, half of the angle. That's why by 2. So for this also some marks are there. During procedure you have to write that one. So taper turning, the next step, and afterwards thread cutting. 1, 2 thread cuttings. One is 11 TPA RHS. This one is RH, right hand thread. Right hand thread means the carriage moves from left to right. Left to right. No, not left. RHS means from tailstock side to headstock. Right hand to left hand. That is RHS. And this one is LHS. Left hand V thread. V means V thread. The tool is V shape. We will use. That's why V thread I mentioned. This LHV means left hand. That is the carriage moves from left to right. That is from headstock to tailstock side. I think during explanation we did wrong actually. I think I have taken this is left hand, and here right hand I think I took. So for explanation purpose only, and now I am telling, but in the afterwards some PowerPoint we explained, I think in this one only, but it is shown as a reverse. Okay. And after thread cutting, knurling, this one, knurling. So here we have to engage back gear, and a tool change will be there. Depending on this shape, that type of knurling tool which contains that one we have to take. Okay, knurling, this operation. And finally, parting. So these are the operations: facing, center drilling, plane turning, marking, step turning, groove cutting, chamfering, taper turning, thread cutting, knurling, and parting. And I asked my mechanics, they gave these are the operations. First, facing, center drilling, plane turning, step turning, groove cutting, chamfering, taper turning, thread cutting, knurling, parting. They are given in this fashion. Myself, actually, I prepared earlier, but these are the same steps, but some details I have given. How much for idea purpose. and here they have not mentioned marking. I mentioned their marking. That is the difference. Okay. And next one is taper turning by swiveling method. Taper turning by swiveling method. 1 minute. Please excuse me. Sir. ఇప్పుడే క్లాస్ బిగిన్ చేసేసారు. ఒక హాఫ్ అన్ అవర్ అండి. ఒక హాఫ్ అన్ అవర్. ఓకే సార్. 2:30. ఓకే. And I think you have seen this video. This is 1B. You 23 minutes to 30 minutes. It is explained. Taper turning. Just you observe. Afterwards, we will see.
Formula is capital D minus small d by 2 into L. So here, this is the 18 diameter and small diameter is 10 and length is the 20. So by doing calculation, the angle is 11.3 degrees. So now we set the angle. So open this. And one more nut also. So when you open this, you can take any angle. So here, this is a 0. Okay, 0 is between the 11.3 degrees. So after that, you have to type it. Previously we done step turning. When you are doing step turning, you are moving the carriage angle. This carriage arm moves on the parallel way. So we are getting the plane axis. Plane surface. But now to do taper turning, we have to use the compounded standard. So in this method, the cutting tool will incline and axis is parallel to the base axis. Now we have to move the compound side angle to get tapered down. So the machine to get the diameter reference, then it put the increase the transfer depth of the by using crosswise to give the key, use the compound with mapping. Increase the depth of the oil. So every time the engine is increasing. Fundamentally increasing. So we have to do a total value 220 mm. Then the diameter is automatically coming to the 10 mm. So finally, take the reference at the 20 mm length, with reference 18 diameter, then take the back. So in this method, this compound slide moves little length only. So it cannot produce long lengths. So by using this method, you can do external and internal also. Internal taper down.
So for this problem, here 18 and here 23. So half taper angle, that is tan alpha equal to capital D minus small d by 2L. So tan alpha, this one, and alpha is 5.7 degrees, 5.7. So compound swivel method you have to do. On the the carriage contains H-shaped casting saddle. On the saddle cross slide. On the cross slide compound slide setup will be there. The compound slide, one plate will be there, circular, and degrees marking will be there, and on that this compound slide will be there, and on that tool post. Okay, so we know alpha. Now we have to loosen bolts both sides on the plate, and the compound slide. 2 bolts are there. I think he has shown already. we have to loosen it, and we have to set, and we have to do this taper. You have to remember, during taper turning, you have to operate only the compound slide only, not this a bigger wheel, carriage wheel. If you are moving, you won't get taper. So you have to take care that only that compound slide only you have to operate for the taper turning. That is for angle cutting. You have to use compound slide only, that wheel. Okay. And next one is our job. This one. Next, this part is over. My aim is, if you understand this process, you can write any shape. That is the thing. Okay. So next, this threading. Maybe I have shown here wrong. LHP, RHP, I think some thing, but the formula is change gear ratio equal to speed of the lead screw by speed of the workpiece. That one. So gear ratio finally is driver gear teeth. Driver gear by driven gear. That is number of teeth on the driver gear. And this one, this is the formula for the gear ratio. By using this, we have to select the gears which are required, and actually one set of gears will be there, one set. So for matching those set, we have to say, suppose 1/10, then 5/5 or into 4/4, like that we have to take. I think I will explain here. By using this 11 TPA RHS, okay, that calculation is okay, but I think in the job afterwards I will show that. Say gear ratio, so we have to cut 11 TPA, one is RHS, and the second one 14 TPA LHS, right? So here pitch of the screw to be cut by pitch of the lead screw, same thing, equal to, for the 11P, this one, our lead screw TPA in our workshop entire only 8 TPA. Okay, 8. And the TPA on the job is 11. This 11. So 8/11, right? And 8/11 into 4/4. So we are having 32 gear teeth gear and 44 gear teeth drive gear teeth we are having. That's why 4/4 we multiplied. So for the during gear setting, driver gear 32 and driven gear 44, and where I think in this one itself it is there. You can see here, this is right hand, right? Actually, in any textbook, this diagram will be there. This is the setup, tumbler gear mechanism setup. But you can see this is our gear, our lathe machine, this one. So you may confuse. This setup is not there here. So actually in these lathe machines, this setup is in this housing inside of the headstock. Afterwards, I will show that. You remember, that's why I shown separately. Tumbler gear mechanism is inside of the headstock housing. Headstock house. Inside, these gears are there. So you don't confuse. That's why I prepared this thing. And another thing, right hand thread. So this is the lever, and moving topwards means here space is there. You remember this. This is upwards. Then we will get right hand thread. Right hand thread. This lever must be top, and middle, that is neutral. Bottom, that is LHS, left hand thread. Okay. And another, this one is driver gear. This is a driver gear, and this is driven gear. Driver driven, and this is idle gear or intermediate gear. It is called idle gear or intermediate gear, this one. And these three, tumbler gear, no, this one, this tumbler gear, and driver gear or stud gear, both are same. Driver gear or stud gear, this one. Driver driven. Okay. And the position upwards, right hand thread. And this tumbler gear mechanism is inside of the house. You have to remember this point. And next, say LHS. This diagram is same. LHS. This is a top position. Top position LHS. And the previous one, this one here, it is gap is there, that is RHS, and here gap is there, this is LHS. LHS, this one, left hand thread. And for the this is the same thing. Okay. And for the thread cutting, the diagram, say lead screw, we have to engage by off net, and this, say afterwards I will explain that thing, and some other content is there. And this is the calculation, 32 by 44 for 11 TPI or 11 TPI. And this is 14 TPI, 8 by 14. 8 by 14 into 4 by 4, that is 32 is driver and 56 is driven. And this is a simple train with one idler gear only. Simple train. Okay. And I will give this PPT also. I will send in our theory class. I think these are explained. Hello.
No, sir, not yet.
I think this PPT only by Venugopal prepared. I think this is the PPT. They changed the name and they will explain. This one also I will send it to you. From this only I took the they will explain left hand thread, right hand thread, all those things in the class also. This is compound gear train. Only we used the simple gear train only, one with one idler.
So what do we mean by idler, sir?
Idler for the shifting purpose we will use. For the connection, sometimes directly we can't connect. Some problem will be there. It can't contact. So with the help of the idler, we will connect. And another thing, say driver gear, if it rotates here in this direction, so it rotates here, and both are rotate in the same direction, this one and this one, but this is opposite. This one, you asked me the idler gear, right? Say suppose inside this is the shaft, on that this gear is there, okay, and here is the lead screw here. Then how do you connect this one and this one? Because some constructional problem is there. Say here the shaft, that is here one shaft, that gear is there, and here the lead screw is there. These to connect these two, one idler gear, one gear we will connect with this. This is called idler gear or intermediate gear. Okay. So this is the gear calculation part is over, and next. And for the thread cutting, you can note down, or you are having this 33 minutes to 42. And afterwards, I will show some more thing.
So after tampering, you have to do thread cutting. So thread cutting means equal grooves and equal length, equal depth on external or internal surface in cylindrical shape what is called threads. So to do threading, we need to do some calculation, like gear calculation. So gear calculation equal to gear ratio equal to driver gear by driven gear. It is equal to pitch of the workpiece by pitch of the lead. So here the required TPI is 1/16. So the lead screw has a 8 TPI. So the pitch is, the ratio is 1/2. So this thread cutting is not possible in manually. So to do thread cutting, this one is called tumbler gear. This is now neutral. So we have to open this, and it has here 3 positions. Now it is neutral, and first one is the, this is a down position. So when it is down position, the carriage moves right to left. So you can produce right hand thread. So when you need left hand threading, so this can be taken up to upside. Then the carriage moves left to right. Then you can produce left hand thread. So middle one is the neutral. Now we are doing right hand threading. So take it to downside. Then side it. Down position, this gear is this position. So when it is down position, this gear is meshing with spindle gear. So along with this gears, now leads to rotating. Then lead screen rotating. This is the half line. So in this, so this is the half line. So in this is the half nut. This one is the feed clutch and feed lever. These two are used to get automatic surface finish, and this is used to get thread cutting. So when it is down pressure, travel is rotating. So when you engage the feed clutch, now we are getting the cross feed. So by using the cross feed, you can do the pressing operation by automatic. So when you change the low portion upside, now we are getting transfer feed or starter feed. So by using the starter feed, you can do change turning or step turning. So now you are doing thread cutting. So keep it to neutral, then you can engage the half nut. So it is moving more speed. So you have to use back gear here. So to engage the back gear, first we need to disconnect the one pin is there. You need to disconnect the pin and keep it side. Then engage the back lever. Now it is in back gear. The basic portion is same, but RPM is there. Here this is the change gear drive. So here this is the driver gear and this one is the driven gear. This middle one is the intermediate gear. We link these both gears. So this driver is related to the workpiece and driven is related to the wheels. If the driver and rotation is same, then you can get the this impression is to the coming to the workpiece. So here the lead screw has a 80K. If the RPM is same, then get here 80K. Now our required TK is 16 now, so it is taken to double. So this number of TK is the 32 and this number of TK is the 64. Now this is called half nut. So when you are removing the half nut, so it is catching the lead screw. So it will move automatically according to this driver and this ratio. When the ratio is 1/2, it will automatically move according to 1/2 ratio. So this is everything how it is done. So this is the limited zone. This is the taking this one. Then before starting the thread cutting, we have to calculate the depth. So the depth is this standard 0.64 is the standard. It is 0.64, our pitch is 1/16. So 0.64 into pitch. Pitch is 1/16. So in the calculation 0.04 inches and convert into mm, that is 1.016 is the final depth of it. Setting down, it shows down where to engage the carriage portion every time. So we have to select one constant region. First, take the reference, the diameter, and set it 0. Then place the half nut at the constant position and any number like every time like this we have to follow the same number. Here we have to disconnect the half nut and take it to dark. Now again, increase the width of the 7.1. So here we have to give the width of the every time 0.1 only. Like that up to 1 mm. Okay. So here undercut is made. Here release the tool.
I think just now you saw that this threading, and here also you can see thread cutting and knurling, because we are doing at low speeds. So back gear engagement for the thread cutting, we are engaged back gear and we have completed. So on the immediately by changing that tool, knurling tool, we will perform. Already back gear is engaged like that. Okay, so the remaining operations you can understand easily. You can write for this or any other also in the record. Perform various operations with the threading operation, thread and knurling, these things, taper turning. Okay, this is one experiment, or where you can divide into two also, you can write for the record. Okay, in the record, tools and materials required, you have to write. Tool, say suppose here 150 and we are supporting, it is okay. So suppose 60 mm is the workpiece. For the holding, 30 mm you add, you have to write that much length is required. That is the thing. Say 60 required, then how to hold, etc. That problem comes. So for holding, you have to take extra 25 to 30 mm extra, right? And tools. What is the tool? Cutting tool you have to mention. High speed steel we are using. So you mention high speed steel cutting tool, single point cutting tool. On the lathe machine, single point cutting tool. Drill bit means multi-point cutting tool. Milling cutter, multi-point cutting tool. Reamer, multi-point cutting tool. Grinding wheel is multi-point cutting tool. So you have to mention, okay, in the record, speed, feed, depth of cut, minimum, what is the speed, feed, and unit also you write. Okay. And this one, and one more thing, where eccentric, no. For this gear understanding, I prepared this small clip. Yesterday I joined the same thing I explained in the PPT. That left hand, right hand, those things. You can see the inside. That's why these inside, those are tumbler gates. Because in the main video that time we did not think, and here now the problem is in the machine shop power is not there. That's why some line problem is there. That's why we operated by hand only, by rotating the 3-jaw check by hand. For showing you, this I prepared yesterday.
Okay. Now. With the neutral position, with the left hand position. And this is for right hand press cutting position.
Inside those things also come. You
Right hand, cut right hand side. You have to make it down and again lock this screw. Now it is ready for to cut right hand threads.
To do level 14 gear, the required gears are driver gear is 32 and steering gear is 56. Then the lever position should be, the tumbler gear position should be down.
So he is explained our gear ratio.
Position. Then the carriage moves to right to left. So you can produce right hand gear. To do flip coding, the gear ratio is driver gear by given gear. It is equal to pitch of the workpiece by pitch of the links. So here the pitch of the workpiece is 11 to 8, the pitch of the links is 8 to 8. So we have to use here 32 gear and we have to use lead slip gear is 44 gear. So to do rectangular cutting, the tumbler gear should be taken upside. Then the carriage moves to left to right. So you can then the slope is going to left hand.
Now to cut LH threads, let's connect the tumbler lever. These three are tumbler gears. This is the thread. Have to connect this gear. For the right hand thread, let's connect like this.
You see here 1, 2, 3. These are three in the housing. So right hand thread means this will mesh with this. This is this. Even LHS means this and this one. Actually, with the hand, we are rotating headstock. That is the problem. That's why it is very slow.
So to do thread coding, first you need to calculate the gear ratio. After that, you have to engage the tumbler. According to the left hand threading or right hand thread. So to do right and ready, the liver position should be down, and then after that, and this is the half nut.
Often it, I think in the first year, you have seen or not, I don't know. Through this lead screw will be fitted actually through this. This is upper part of a half nut, upper part of the half nut, and this is the bottom part. By engaging the half nut means this one, it will fix with the lead screw. That is the half nut engagement, half nut for the thread cutting. This one, and now also you can see it. We are showing.
So we need to engage the half nut. So we need to engage the half nut.
Now you can see that half nut engagement. Now it is fixed, losing. So by engaging along with the lead screw movement, the carriage moves. That is the thing. And 1 minute. Okay, afterwards, once again it will come that.
In case of event threading, you can engage on any number in 1, 2, 3, 4, any number. In case of odd threading, if you engage on 4, next time you can engage opposite 2 or 4 number. If you first time engage on 3, then you can engage 3 or opposite number 1. You can engage 1 or 3. That is for odd threading. You need to do number of times. Every time the carriage, the tool position should be engaged same place. Then you can get the same part. So to engage the tool position at same time, this is called thread chasing dial. It shows the way to engage the carriage position. For example, this leads to having a 8 TP. So when you are doing 8 multiples, like 8, 16, 24 TP, you are doing multiple TP. So this is no need to use thread chasing there. In case of even threads, like 10 TPI, 12 TPI, 14 TPI, then you can use thread chasing there. And see this? This is the one engaging position, and it is marked with 4 divisions. So in case of even threads, you can engage on any number like 4, like 1, 2, 3, 4, and any number. In case of odd threading, like 11 TPI, 13 TPI, like this TPI, you have to engage on, if you engage on 1, and next time you have to engage on 3 number.
Here, one thing you have to remember, suppose on a lead screw, we are having 8 TPI. So multiple, that is even 4 also, 4, 8, 16, 24, like that. For that TPI on the workpiece, say on the workpiece, there is no necessity of this thread chasing dial. Automatically, by engaging off nut, we can cut it. But whereas, say suppose even number threads, say that 14 TPI we have to cut, then we will engage off nut, and this it will rotate. While rotating, here 0, it is coincide on this 10, 12, 14 dpi. That is for even threads. any number of thread chasing dial we can engage. That is 1 or 2 or 3 or 4, any number. 1, 2, 3, 4, any number we can engage during even threads. So suppose we have to cut 11 threads, that is the first one, 11, 13, 15, that is odd thread. Then we have to engage only, say suppose in the beginning, we start with number 1, then we completed the first time, that is 0.1, each time 0.1. You have to calculate that given formula, a 0.64 into something, that I think 64 into that pitch. So you will get 1 point something. Each time 0.1 mm depth only you have to give in the thread cutting. So odd thread you have to cut. And one thing, say here is the job. So you move slightly away from the job, the carriage, because of, for engaging etc. we require some space. So if we start 1 for the odd thread, then 1 rotation is over. Then we can engage next for the second time feed 1 or 1, 3. Any one only we have to give, 1 or 3. It is written, you can see 1 or 3. So suppose in the beginning 2 we have given, then 2 or 4. Here it is only 3 division it is shown, but actually 4. So 1 or 3, or otherwise 2 or 4, these 2 for the odd thread. This thing you have to remember. Okay, thread chasing dial is used for even and odd thread, and for the, because our lead screw is 8 TPI, so multiple of that TPI, then there is no necessity to engage this one. Automatically we will get, but that calculation, gear calculation will be there. Okay, this is the regarding that first 2 experiments are 1, right? And the next one is eccentric turning. Eccentric turning. So for the eccentric turning, we will give 25 mm rod or 30 mm rod. Okay. So initially here 25 plus 22 is given, that is 47, say 50. 50 plus holding 25 or 30 mm length rod you have to take. Okay. Then initially you fix this in 3-jaw check. In 3-jaw check you fix it, and you can do on 4-jaw check also, but unnecessarily time it will take, because in the 3-jaw check self-centering, initially we have to do turning, right? So automatically 3-jaw check means automatically self-centering we will get, and the bigger one, say 24 mm dia, we have to perform by facing. First operation is facing, next one is plane turning for the length of this much. Okay, and the entire length facing plane turning is over. Next step is by using vernier height gauge, or the another setup is there, that is combination set one is there. I will show that. With that diameter marking you have to perform diameter marking, and yeah, what we are doing our practice is only one line we are doing, but actually you have to mark at 90 degrees that diameters also. But one dia only we are marking, we are showing, and center line automatically we will get, and after that the shifting. We have to mark this, and with this divider with 5 mm radius we have to mark the circle, and if required that punching is required, that center and on the circle also. So center line marking, center line and offset center, and by using divider radius of 5 mm circle from offsetting center and punching of the offset circle. Okay, and the main thing comes now, and this one we have to perform. So this center, so suppose if we are placing in 3-jaw check, we will not get this center. So for the eccentric turning, now this one we have to fix in the 4-jaw check. 4-jaw check we have to fix, and while doing that, we have to take that precaution is, I have to show, not that. Okay, during job, that one I will show that. Just you observe.
So the diameter of the largest part is 20 mm, and the eccentric circle has a diameter of 10 mm. So we need to locate this center and this point and this axis. Okay, so for that, first what you have to do is measure the height of this circle on this. So bring the scale, set it to the top of the workpiece. From that you can measure the height of the maximum point of the workpiece. So let's say, assume that it's 60, okay, at this point. So you know the maximum height, which is 60. Okay, then you find out the center. Okay. So for finding the center of this, because you know diameter is 20, you just subtract 10 and you will get this point. Okay, so suppose we have like reduced it by half. So this is half, and then you mark the center line with this, like this, by inscribing it. Okay, so you got this center line. After that, what you have to do is you have to find the exactly perpendicular center line. For that, take out the magnetism for this, rotate it, keep it with an angle plate, and check if this axis that you mark is exactly parallel to this angle plate or not. If it's parallel, that means like you can move on to mark the horizontal axis on the workpiece. Okay, so it's parallel, assume it's parallel. Now again bring it to, like, from the maximum height reduce 10 again, and again cut another line like this, make it solid, and then you would have got both axes on this side. So from that you go to exact center point. Okay, after this you have to get the center point of the eccentric circle. From top you reduce 5 centimeter, either from the midpoint you go 5 up, or from the top point you go 5 down. Then you will get the eccentric center also. So after you get the eccentric center, put a point on that and point to the center of the eccentric point, so it's clearly visible. Okay. After this you go to the lathe. So for eccentric turning, this tool post has to be rotated by an angle, and that will be set probably in the beginning only, and the cutting tool will be on. Okay. So what you do then is that you place this inside, and you have to center this according to the eccentric center of this tool. So let's assume the eccentric center is at this point. So to center it according to the eccentric center, you have to bring the state dead center in contact with the eccentric center.
Sir, the screen is not completely visible, sir.
Pardon?
Sir, the screen of video is not completely visible. Only the lower half is visible.
Now?
Yes, sir, it's visible.
Actually, I have given this link. Afterwards also you can see this. Main thing is now there are different methods are there. Okay, marking by using the height gauge is one thing, and another in our video some the other by using combination set he marked where this diameter marking. Okay, and what he has done is one line, and with the center he draw, and from the edge, because already it is plain turned workpiece, so on that line from this surface, that is from end,
Okay, one more thing before this.
from end point to how much offsetting he marked that.
When the eccentric center is here, the axis which is
Here in our video it is not good. Not good means they are not explained properly, because that time student point of view we have not thought, but afterwards this time. So this line, that diameter line through center, what we have to do is, this is the four-jaw check, like this. So this line must be in this direction.
directly like perpendicular to that eccentric center should be in alignment with these two jaws.
Then if this is if in this fashion we do, it is easier to fix that eccentric circle. What we have done in our job, somewhat it is difficult. It is easier in this.
Once you got that step, so let's assume that the eccentric center is here. Now you notice that the dead center is not coinciding with this eccentric center. So all you have to do then is like center this workpiece in a manner that it coincides exactly with the tailstop. After you've done that, the workpiece is centered. Then
that is, suppose this is the thing, that center is above, then that bottom one we have to loosen it and we have to tighten it. That is, the workpiece we are shifting in this direction. So somewhat we have to manipulate. If the workpiece is to be shifted to bottomwards, then bottom one here it is, we have to loosen it and we have to tighten it. And for the sides also, suppose we have to shift it, then according to that, one side we have to loosen it and another side we have to tighten it. In this fashion, we have to coincide that offsetting center with the dead center, and after that we can do turning. It is as common as plain turning. Okay, this is the one video, you go through it.
and you can start the machining.
1 minute, I will
Take this tailstop back.
this file I have sent, this some 19 or thing. In this, these videos are given eccentric turning marking. It is explained in Hindi, but it is very clear. He used the height gauge, vernier height gauge, this one, and the operation also he has done. You go through these two, and now this video just now you saw this. Okay. Actually, this is it may useful. I thought that's why I have given these drives, etc. Just you go through it. If you feel it is useful, you use. Otherwise, the other method. I took from some books only, but I placed it at one place. In this thing, PDF file, those links are given. Some calculations, etc., different pictures, all those things. And I think in the theory also they will explain. This is from Raghuvamshi textbook. And some pages I kept from the Al Hassan or something. 6 pages or so kept like that. At one place, it may useful, I thought. Okay, links are given here. Along with our videos also, you go through it. Okay, in this file, those links are given.
तो आप देख सकते हैं हमने अगर रिवॉल्विंग पास लाके उसको केंद्र के उससे हमने पहले इन दो को हमने इन दो चक्कों देखे हैं तो इसके हिसाब से केंद्र से ये किधर है कि इधर है केवल इन दोनों की बात करेंगे
They have done marking by using vernier height gauge.
बिंदु से ये रिवॉल्विंग सेंटर का इधर है ना यानी इसको थोड़ा सा इधर करना हमने तो अभी केवल हम इस पे फोकस कर रहे हैं ठीक है तो यानी कि पहले इसको लूज करना पड़ेगा थोड़ा सा आ गया बराबर आ गया नो सर अभी नहीं थोड़ा सा रह गया थोड़ा सा रह गया
So one side he is loosening and opposite he is tightening. That is shifting. He is shifting.
ये पकड़ेगा ना अब उसकी लाइन में है ये अब हमारा खेल है इन दो का चल रहा है तो आप देख सकते हैं हमने अगर रिवॉल्विंग पास लाके उसको केंद्र के उससे हमने पहले इन दो को इसके बिल्कुल बिंदु पे इसके एक ही लाइन पे ले आए तो यानी इसके सापेक्ष ये दोनों को एडजस्ट करते हुए वो बिंदु हमें इसके लाइन पे ला चुके हैं अब हमें इस जॉस को इसको हिला के ये ठीक करना है बस ठीक है अब ये है ना जो अब हमें इन दो पे काम करना है तो फिलहाल आप देख सकते हैं जो बिंदी है जो उसका सेंटर पॉइंट है वो इसके रिवॉल्विंग सेंटर के पॉइंट से थोड़ा बाहर है तो हमें इसे लूज करना है इसको कसना है ऐसा कर देंगे तो ऑटोमेटिक क्या हो जाएगा वो केंद्र पे आ जाएगी तो हम यहाँ ध्यान में रखते हुए इसको लूज करेंगे
So offsetting
ठीक है
for the eccentric center.
आप इसको करें आगे देखो हल्का सा है ना अभी भी किधर है अभी इसको फिर लूज करना पड़ेगा और कसना पड़ेगा उसे उसको
In physical mode, say suppose you are doing with slight practice, you will get automatically. The setting is not a problem.
जॉब नहीं लेनी चाहिए अपनी जगह अगर जॉब मिल गई ठीक है काम हो जाएगा तो फिलहाल अगर आप देखें जो केंद्र का बिंदु है वो रिवॉल्विंग के बिल्कुल मिड पॉइंट पर रह के वो घूम रहा है इससे ये समझ में आता है कि 90% तक हमने इसको सेंट्रिक 2 कर लिया है ये शॉर्ट तरीका है तो आप देख सकते हैं उसके जो रिवॉल्विंग सेंटर के सामने बिल्कुल बारीक बिंदु है, वो तकरीबन उसी के केंद्र में रहते हुए घूम रहा है, जो ये पहचान करता है कि जो हमारा एसेंट्रिक टर्निंग की जॉब हमारी तकरीबन सही लग चुकी है। अब हमारा काम बाकी बचा हुआ हम क्या करेंगे, जो यूनिवर्सल मार्किंग ब्लॉक होता है उसके थ्रू हम प्रूव करेंगे। ये आप देख सकते हैं इस पॉइंट से भी बाहर है और इस पॉइंट से भी बाहर है ना, तो यानी बहुत मेजर बाहर है। तो ऐसी कंडीशन में क्योंकि पूरे एरिया में बाहर है, हम क्या करेंगे, दोनों को हल्का लूज कर देंगे। बस ये ध्यान रखेंगे ये हिले ना, ठीक है। इनको दोनों को एक साथ लूज करेंगे तो क्या होगा, अभी हमें क्या करना है, ये पीछे है, सॉरी अगर ये पीछे है सर्किल हमें इधर करना है, इधर इनकी तरफ, ये लूज होके इधर आएगा।
This is a final tuning. By using this marking, is it rotating on that or not? Then fine tuning he is doing.
ये हिला नहीं चाहिए, ठीक है, ये दो कसे जाएंगे। तो मेरा कहीं वो लगभग नहीं हो गया भाई, पूरा चाहिए। अभी देखो, अब हम दो से पकड़ेंगे, ये भी बाहर है, ये भी बाहर है ना, यहाँ से तो ये पकड़ में आ रहा है, यानी इस पोजीशन से और इस पोजीशन से ये थोड़ा बाहर है। यानी इसको फिर क्या करेंगे हम, इसको यहाँ से भी ये भी लूज होगा, ये भी लूज होगा। तो मैं दो एक साथ पकड़ रहा हूँ, फर्क क्या है, ठीक है। जब मेरे एक से नहीं हो रहा तो मैं दोनों एक साथ पकड़ रहा हूँ। हिलने तो बड़े हिलना नहीं चाहिए, हिलना नहीं चाहिए वो। कटिंग अलग चीज होगी भाई, विकास हो गए भाई, मतलब तो इसे कहते हैं फेसिंग से फेस से थ्रू करना। तो अब हम इसकी टर्निंग स्टार्ट कर रहे हैं। उसके लिए हमें क्या करना है, इसको चक्कू घुमाना है स्लोली, और बस ना 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 मैक्सिमम पॉइंट देखना है कि कहां पर टच हो सकता है। तो हमने देखा कि जो ये लाइन जा रही है ये इस पॉइंट पर मैक्स
And after this maximum side we have to keep the cutting tool. Otherwise, suppose if we are keeping in this, then all of a sudden a load will be there, impact, and our tool will fail. So the maximum this side we have to fix it. Tool.
मैक्सिमम सबसे पहले टूल यहाँ पर एसेंट्रिक में टच करेगा, तो हमें कट अब यहाँ से शुरू करना है। गड़बड़ क्या होती है, घुमाओ उसको। लड़के गड़बड़ क्या करते हैं, टूल को जब नापते हैं शुरू में इस पॉइंट पे यहाँ से यहाँ तक चले जाते हैं। उसमें क्या होगा, उनको ये समझ नहीं आता कि अभी आप अगर यहाँ पहुंच गए और मशीन ऑन करी तो हुआ क्या, जैसे टूल यहाँ पर है और अब ये पूरा एक ये टूल आपका ये टूट जाएगा। तो हमेशा ये जो सर्किल बना है इसे मैक्सिमम कितनी दूरी पे ये टच कर रहा है वहां से टूल को टच करना है, कभी भी उसके क्लोजेस्ट नहीं जाना, नहीं तो आपका टूल या आप एक्सीडेंट करेंगे या तो खुद चोट खाएंगे या फिर जॉब में गड़बड़ कर देंगे। इसके अलावा आपको ध्यान रखना है कि जो आपका टूल है ये थोड़ा एंगल में आपको सेट करना होगा, क्योंकि चक से इसकी दूरी अभी ज्यादा नहीं है। तो ऐसा ना हो कि कटिंग करते हुए आप आगे आए और आपका ध्यान ना रहो और आपका ये जो टूल होल्डर है या टूल पोस्ट है ये इस चक के जॉ से भिड़ जाए। तो बेटर है आप टूल को हमेशा थोड़ा इस तरह से रखें ताकि केवल कटिंग पॉइंट सबसे आगे रहे, बाकी पोर्शन सारा पीछे रहे। तो आप देख सकते हैं केवल एक पॉइंट से ये टच कर रहा है। अब हम क्या करेंगे, उसको आगे नहीं करेंगे भाई, उसको पीछे लाओ। ये क्या करेगा, आगे जाएगा, हमें आगे नहीं जाना, हमें साइड जाना। इसको घुमाओ, वही तो गड़बड़ होनी है, वही तो समझा रहा था मैं। हमेशा जब भी देंगे हमने इससे कट देना है, ना कि वो कर दिया तो टूल आगे चला जाएगा, वो तोड़ देगा टूल। आप देख सकते हैं ये वाली कौन सी स्लाइड है, लॉन्गिट्यूडनल, यानी टूल अब आगे को जा रहा है। यहाँ देख सकते हैं स्पीड हमेशा स्लो रहेगी, अगर स्पीड तेज कर दी तो ये तोड़ देगा। अभी इस लड़के ने गलती क्या कर रखी है, ये टूल एक्सेस फालतू बाहर निकाल रखा है। ऐसे कंडीशन में कम से कम टूल को हम बाहर निकालते हैं, टूल होल्डर के पास ही रखते हैं, क्योंकि ये टूल थोड़ा मोटा टूल है, इसीलिए ये लोड सहलेगा। अदरवाइज अगर पतला टूल होगा तो वो टूट जाएगा। इसमें आप देख सकते हैं एसेंट्रिक टर्निंग में झटके लगते हैं, तो बेटर है आप मोटा टूल का यूज करें। इस एंगल से भी देख सकते हैं आप। फिलहाल हमने माइनर कट लग के आपको दिखाया है कि सब कुछ सही है कि नहीं। जब आप जो एसेंट्रिक टर्निंग की टर्निंग स्टार्ट करेंगे, शुरू में स्पीड कम करके एक माइनर बहुत माइनर से कट लेके उसको कंप्लीट कर लीजिए, उससे तसल्ली हो जाएगी कि हमारी सब कुछ सही काम कर रहा है। उसके बाद आप अपने चक की स्पीड बढ़ा सकते हैं और उसका डेप्थ ऑफ कट बढ़ा सकते हैं, लेकिन फर्स्ट टाइम पे थोड़ा कम से कम स्पीड और बहुत माइनर कट, ताकि आपको हिसाब किताब समझ में आ जाए कि सब सही है। इसके साथ साथ हमेशा ये जो जॉज है और जो टूल होल्डर है, इसके बीच का गैप भी हमें मेंटेन करते ध्यान रखना है कि ये भिड़ ना जाए आगे पहुंचने तक। अभी क्योंकि हमें केवल 10 mm अंदर तक जाना है, इसीलिए इतना क्लोज चल रहा है। इसके अलावा आप देख सकते हैं जो नॉब के अलावा जो टूल का पीछे का भाग है वो टेपर में रहना चाहिए, ताकि वो टच ना कर दे सामने वाले पार्ट में जॉब के। अभी इसको जूम करेंगे, आपको दिखा देंगे कि जो टूल का पॉइंट ही जॉब को टच कर रहा है, टूल के जो पीछे वाला पार्ट है वो टच नहीं कर रहा है। ये आपको विशेष ध्यान रखना है। देख सकते हैं आप यहाँ पर देख सकते हैं ये एसेंट्रिक टर्निंग होनी स्टार्ट हो गई है। केबल टूल अभी यही कटिंग कर रहा है। जब धीरे धीरे आगे बढ़ता चला जाएगा तो एक कंडीशन ये आएगी, इसकी सारी टर्निंग सारा केवल ये वाला पोर्शन गोल रह जाएगा, बाकी सारा मटेरियल जो आप ये देख रहे हैं सब हो जाएगा। अब आप देख सकते हैं इसकी भी स्पीड हमने शुरू में ट्रायल ले ली है, एक दो कट हमने देख लिया, मार्कर सब कुछ ओके है। उसके बाद हमने इसकी स्पीड बढ़ा ली और स्पीड बढ़ाने के साथ साथ हमने इसका डेप्थ ऑफ कट भी थोड़ा मोटा कर दिया, ताकि थोड़े मोटे कट निकाले। चलो भाई मेरे को स्लाइड दो चक्कर मारिए, छेड़ो मत, मैं उंगली काट दूंगा इसके ऊपर, उंगली रखोगे तो चलो। अब फिलहाल आप देख सकते हो स्पीड थोड़ी तेज है और कट थोड़े मोटे आ गए। शुरू में हल्का रखें, बाद में जाके उसको आप बढ़ा दें। बोर हो रहे हैं हम तो नेक्स्ट टाइम और मोटा कट लेंगे नेक्स्ट टाइम। इससे पंगा नहीं करना, हमेशा शुरुआत इससे होती है, इसको बहुत सोच समझ के स्लोली बढ़ाना आगे। अभी आप देख सकते हैं ये जो आपको स्टेप दिख रहा है, ये देखिए ये और ये एक ही कट है हमारा, आप देख सकते हैं। काफी मोटा कट हमने इसमें दिया है। तो ये हमने शुरू में पहले हल्का ट्रायल में बहुत माइनर कट लिए, बाद में धीरे धीरे हम डेप्थ ऑफ कट बढ़ा रहे हैं मशीन की स्ट्रेंथ के हिसाब से, क्योंकि ये मशीन HMT की NH22 है और हैवी मशीन है, तो ये इतना मोटा कट झेल जा रही है। आपको भी इस बात का विशेष ध्यान रखना है, कट उतना मोटा ही करें जितना मशीन झेल पाए। आप देख सकते हैं इसकी शेप चेंज हो रही है, बहुत फ्री कर लो, फ्री कर लो। और ये गोलाई अपनी लेना शुरू कर रहा है, आप देख सकते हैं यहाँ पर। ये धीरे धीरे आप जब देख रहे हो ना, यहाँ से छोड़ के कट यहाँ पर आ गया, तो अब ऐसे करते 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 ये बिल्कुल गोलाई तक आगे बिल्कुल ऐसे गोल हो जाएगा। बस यही काम है, बस कट का ध्यान रखना है। आप लास्ट में आपको हम केवल गोल में जब ये पहुंच जाएगा अब तभी ही दिखाएंगे। और ये लास्ट कट है। अब हम क्या करेंगे, फाइनल कट है तो इसको पीछे भी ले जाएंगे टूल को, यहाँ से करके इसको टूल को हम पीछे लेके जाएंगे। इससे क्या होगा कि जो कमी पेशी होगी दोनों साइड पे सही हो जाएगा, 90 डिग्री पूरा आ जाएगा। अब हम मशीन को बंद कर रहे हैं, तो आप देख सकते हैं इसकी फिनिशिंग कितनी सही आई है। ये सब राउंड नोज का कमाल है। जो लास्ट फिनिशिंग से पहले हमने फिनिशिंग कट से पहले हमने उसको टूल को ग्राइंड कर दिया। तो उम्मीद है आपने वीडियो लास्ट तक देखी होगी और अब आपको एसेंट्रिक टर्निंग की मार्किंग, उसके साथ साथ उसकी टर्निंग वगैरह सब आ गई होगी।
So this with the same person 2 videos with the marking and performing. Also, you just go through it, and our video also you go through it. Some other process they explain. Plane turning is same for all. Marking and this difference. Okay, so you write both the experiments, and we will send the link by Monday or so. With for that link, you have to upload these 2 experiment folders. Okay.
In inclusion, the opposite. Okay, the procedure is vice versa. Okay, so this will take some time. Such that the pointer should move along the circumference of this eccentric.
All these links I have given to you in the document. It is there.
Finally, finally then, the axis of this eccentric matches with the axis of the blade. Okay.
Okay. And this PPT file and the yesterday prepared video, I will post it. You go through it, and still if you are having any doubts how to perform, etc., also we will see. Right? Sir. Right, sir. నేను రమ్మన్నా వస్తాను. ఓకే, అవును, అలాగే సార్. ఓకే ఓకే ఓకే. హలో వైష్ణవి, ధనంజయ్, hello.
Yes, sir, you are audible.
You are audible, sir.
You go through the videos and these try to understand says these experiments, and you imagine you are doing. So if you are having any doubts further, we will show while performing in the workshop also. Okay. And you write these 2 experiments, and we will send the link. You have to upload for that. And in the next class, the other shaper and drilling and tapping, I will discuss those 2. Okay. And the material is there. Try to understand, and you write on your own words. That is best way to learn also. Don't copy blindly. Karthik Krishna.
Yes, sir.
You are here just now. I am seeing. Okay. Okay, we will meet in the next class.
Excuse me, sir. Sir, what is the deadline for the submission of records?
So how much time you require?
Next week, sir, at least.
2 weeks.
Okay. By next week, Saturday, you take time. Okay. It requires how many hours? 2 hours maximum. You will read once again and you will see. Okay, you take 1 week time. Today is Thursday. And next Friday you can upload. What is there? 1 week time. Right? And we will meet in the next class, 1:30. And I will go through the once again that 2 related videos. If any further inputs are required to understand clearly, I will prepare and I will present those things also. I want to present, I think, that calculation. Say drill, anyway, you will read the radial drilling machine, and that thing, and the marking also you can do easily. But that calculation part, I think we have shown enough. But if it requires, also I will prepare those videos. I already instructed my people in the next week, Monday or so, we will prepare if required, and during the class we will discuss with that also. And also you go through it. If any doubts are there, we will see. You can ask. Okay.
Okay, sir.
Okay.